Welcome to CARB's tester training for Clean Truck Check. This module only covers the requirements regarding submission of a vehicle's onboard diagnostics, or OBD, test results data in the Clean Truck Check Reporting Database, CTC-Viz.
Your objectives for this module are to learn general information about the OBD system in vehicles that monitor for emissions-related issues, and how these OBD systems are utilized as a vehicle emissions compliance test within Clean Truck Check. Some of the most important information covered in this module are: what is the OBD system in a vehicle? What are the components of the OBD system? Why is the OBD system needed in a vehicle? What are the benefits of OBD testing? What OBD data is required to be collected? And how to perform and submit an OBD test to comply with Clean Truck Check.
Clean Truck Check requires almost all non-gasoline vehicles with a gross vehicle weight rating greater than 14,000 pounds to pass emissions compliance tests to operate in California. An OBD test is the required emissions compliance test for two groups of vehicles equipped with OBD systems. Group 1 are 2013 engine model year and newer diesel engines and diesel hybrid systems. Group 2 are 2018 engine model year and newer alternative fuel engines and alternative fuel hybrid systems. Only credentialed Clean Truck Check testers are permitted to perform OBD testing and submit the testing results to CARB. Credentialed Clean Truck Check testers are individuals who have successfully completed the tester course, passed the exam, and obtained certified OBD testing devices. Further details regarding when testing is required and additional regulatory requirements are discussed in the regulatory module in this tester training course.
So, what is an OBD system? The OBD system is a standardized system in vehicles whose main function is to monitor the performance of the vehicle's engine and emissions-related components and detect malfunctions in them. Upon detecting an emissions-related malfunction in the vehicle, the OBD system illuminates a malfunction indicator light, or MIL, to notify the vehicle's operator of the detected malfunction. The OBD system also stores information about the detected emissions-related malfunctions. This information is useful to technicians to properly diagnose and repair the malfunctioning components.
It is important to understand that the vehicle's OBD system only monitors emissions-related components and systems. Therefore, the data recorded by the OBD system is related to the performance and status of the vehicle's emissions control components. Examples of vehicle emissions control components are selective catalytic reduction, or SCR, diesel particulate filter, or DPF, an exhaust gas recirculation, or EGR system. Any malfunction in these emissions control components could result in increased vehicle emissions. The OBD system does not monitor parameters unrelated to emissions. For example, the OBD system won't tell you if there's a flat tire or a problem with safety features like the airbag system.
As mentioned earlier in this training, the OBD system plays a critical role in minimizing vehicle emissions by ensuring that all emissions control components are functioning properly and identifying emissions-related problems as they occur. The OBD system in the vehicle provides information to technicians so that they can diagnose and repair emissions-related problems. Moreover, the monitoring of these emissions control systems potentially encourages the design of more durable and robust equipment.
Compared to the traditional smoke opacity testing that has been used as a heavy-duty vehicle emissions compliance test as far back as the 1990s, the OBD system provides more comprehensive information about the vehicle's emissions control system, enabling enhanced detection of emissions and related issues. For example, the OBD system monitors all emissions-related components, including those that impact both oxides of nitrogen and particulate matter emissions, whereas the smoke opacity test only relate to particulate matter emissions. Another advantage of the OBD system to smoke opacity test is the convenience of performing an OBD test and submitting the results. Compared to a smoke opacity test, an OBD test typically takes less time to perform and requires less expensive testing equipment. The OBD test also benefits from a streamlined process for submitting the results.
OBD systems consist of two main component categories, hardware and software. Hardware refers to the physical components of the OBD system that include, but are not limited to, sensors and actuators that monitor emissions-related engine components, the malfunction indicator light, or MIL, that is a visual notification on a vehicle's instrument panel, which lets the driver know if there's an emissions-related malfunction, and the data link connector, or DLC, which is a diagnostic connector port on the vehicle used to read OBD data. The top picture on the right is an illuminated MIL on the vehicle's instrument panel. The bottom picture is a Type 2 9-pin data link connector, which we'll discuss in more detail later in this module.
OBD systems are standardized to ensure consistency across vehicles and manufacturers. These standards are developed by the Society of Automotive Engineers, or SAE, and International Organization for Standardization, or ISO. In the US, all vehicle OBD systems are certified to meet CARB and US EPA regulatory standards prior to sale. OBD systems have built-in verification processes to ensure accuracy in detecting emissions-related faults. For the OBD system to illuminate the MIL, an emission fault must be detected in 2 successive drive cycles. If an emissions issue is no longer detected by the system in 3 successive drive cycles, the MIL will turn off, letting the operator know that the issue is no longer present.
The OBD system is required to illuminate the MIL to alert the vehicle driver when the system detects an emissions-related malfunction. The MIL, as shown here, is a standardized amber-colored engine symbol on the vehicle's dashboard. Operating with the illuminated MIL often results in increased vehicle emissions and can result in a noticeable impact on fuel economy and engine performance. When a MIL is illuminated, the vehicle should be repaired as soon as possible to avoid permanent damage to components. The vehicle will fail the Clean Truck Check OBD test if it has an illuminated MIL. Therefore, it should be repaired before completing the OBD test.
To perform the Clean Truck Check OBD vehicle emissions compliance test, the test device needs to be plugged in to the vehicle's Diagnostic Link Connector, or DLC. The DLC is a standardized connector used to plug into OBD scan tools to assess the vehicle's OBD data. Depending on the vehicle's make and model year, the DLC can have different shapes and colors. In vehicles using the SAE J1939 communication protocol in their OBD system, the round DLC with the 9-pin connector is used. In vehicles using the SAE J1979 communication protocol in their OBD system, the rectangular-shaped DLC with a 16-pin connector is used.
Here are examples of the different types of DLCs used in heavy-duty vehicles. The top 2 DLCs are found in vehicles using the SAE J1939 communication protocol in their OBD systems. The black round connector is known as the SAE J1939 Type 1 DLC. It does not fit into the Type 2 DLC. It is used in vehicles equipped with pre-2016 model year engines. It has a communication rate, or baud rate, of 250 kilobits per second. The green round connector is known as the SAE J1939 Type 2 DLC. It is backwards compatible and can fit into a Type 1 DLC. It is used in vehicles with 2016 or newer model year engines and supports a baud rate of 500 kilobits per second, double the baud rate of the Type 1 DLC. The bottom DLC in the picture is known as OBD2 Type B, or a 16-pin connector. It is found in vehicles using the SAE J1979 communication protocol in their OBD systems. It supports a baud rate of 500 kilobits per second.
The DLC may be located in a variety of areas in the vehicle cabin. The DLC is typically located inside the vehicle cabin in the driver's side footwell region below the steering wheel. The red asterisk on the top photo represents areas where the DLC may be located in the driver's side footwell region. Occasionally, the DLC is located in the overhead region in the vehicle cab above the driver, such as in transit buses. The red arrow in the bottom picture represents where the DLC may be located in an overhead region. In some trucks, telematics or other tracking devices may be plugged into the DLC. These devices would need to be temporarily removed to perform the Clean Truck Check OBD test.
This table shows the types of DLCs found in heavy-duty vehicles of different makes and model years. Please note that this is a general list, and you need to check the vehicle's manual to confirm the type of connector installed on the vehicle.
The Clean Truck Check OBD test is performed by plugging a CARB-compliant OBD testing device into the vehicle's DLC to collect the required data and transmit it to CARB. The OBD data collected during the emissions compliance test includes parameters to validate operation of the vehicle's emissions control components and ensure the OBD test was performed correctly. The table on this slide provides a summary of the required OBD data for Clean Truck Check.
We will now introduce some of the key OBD parameters to be collected as part of the Clean Truck Check OBD test in more detail here. Mill status data. This parameter reports whether the mill is off or on at the time of performing the OBD test. Diagnostic trouble codes, or DTCs, also known as fault codes, are collected as part of the OBD test. The collected data reports whether the three different types of DTCs, active, pending, or permanent, were present at the time of testing. The mill is illuminated when active DTCs are present and designate an emissions-related issue. Pending DTCs are potential faults that have not completed the necessary confirmative drive cycles to determine a potential emissions-related issue as an active fault. Pending DTCs do not impact a pass or fail determination relative to the OBD emissions compliance test, but provide helpful information on potential future issues. Permanent DTCs consist of active DTCs that can only be removed by the OBD system itself. These codes cannot be cleared by a diagnostic scan tool. Hence, the OBD system itself has to self-heal to remove these DTCs by completing the necessary drive cycles without the emissions-related issue present in the vehicle. Additionally, information useful for identifying the vehicle being tested is collected as part of the test. This includes information such as the VIN, engine serial number, and the OBD system's calibration information. This information is critical for validating the performed test.
Another key parameter in the OBD data is the readiness status of the OBD monitors. This information helps determine whether the necessary vehicle operating drive cycles have been completed to allow the OBD system to run and check for emissions-related faults. If the needed drive cycles have not been completed, the OBD system has not yet had enough time to fully determine whether the emissions control components are operating as required or not. Other parameters, such as distance traveled since last DTCs were cleared, number of warm-ups since last MIL was on, and distance traveled / engine runtime with MIL currently active are also collected as they reveal important information about the tested vehicle's operation.
To perform the OBD emissions compliance test, the appropriate testing device interface adapter that attaches to the DLC is required. Testing devices used to complete the OBD emissions compliance test may vary, but in general, will likely operate similarly to the one shown here. Refer to the owner's manual of your specific testing device for installation and operating instructions. Not all OBD testing devices will require a clean truck check tester to perform an emissions compliance test. Data collection and processing for CARB-certified continuously connected telematics OBD testing devices are handled directly by the device vendor and therefore do not require a credentialed tester. Testing with these continuously connected telematics devices is not included as part of this training. In summary, all emissions compliance tests done with non-continuously connected OBD testing devices must be performed by a credentialed tester.
A list of devices that meet CARB's OBD data format submission requirements can be found on CARB's Clean Truck Check website. This list will be continuously updated as new devices become available. Testing devices that do not require a Clean Truck Check tester to perform the inspection will be designated as such on CARB's Clean Truck Check webpage. Please refer to the OBD readiness criteria requirements on the Clean Truck Check Credentialed Testers page for the most up-to-date requirements.
A warm-up cycle means driving a vehicle so that the engine coolant temperature rises by at least 40 degrees Fahrenheit after the engine is started and reaches at least 140 degrees Fahrenheit for diesel engines, or 160 degrees for natural gas engines. Permanent Diagnostic Trouble Codes, PDTCs, are very similar to regular Diagnostic Trouble Codes, DTCs. However, unlike regular DTCs, they cannot be reset by disconnecting the vehicle's battery or cleared using an OBD scan device. The only way to clear a PDTC is to fix the underlying problem with the vehicle that originally caused the PDTC to set and then allow the vehicle sufficient drive time to rerun the monitor that identified the problem in the first place. When the monitor runs without identifying a problem, the PDTC will clear itself.
We are now going to briefly describe the process to complete a Clean Truck Check OBD emissions compliance test. Note that there are multiple testing devices available. However, this process will generally be the same for most devices. Before beginning the test, ensure that the vehicle is parked and the engine is running at idle. Also ensure access is available to a stable internet connection and that the computer used for testing is connected to the internet. In addition, any software from your device vendor that is required to complete the testing needs to be installed on the computer used to perform the emissions compliance test, and the version of software must be up to date to the most recent version. An account with login information should be established through your device's vendor.
As shown in these pictures, connect one end of the testing interface to the computer's USB port and the other end to the vehicle's DLC. Pay attention to the type of DLC as explained earlier in this training.
On your computer, click User Information to enter your user information, which will include your CARB-issued Clean Truck Check Tester ID. The next slide will show you an example screen for entering user information.
A user information menu will appear on the screen as shown here. First, enter information about yourself, including your name, your tester ID the CARB will issue when you pass the exam after this training course, your email address, and password. Your email and password must be the same as the one used when you established the vendor account mentioned previously. Next, click on Login to verify the email and password combination is correct. It is essential that only valid and correct information is entered in this screen to avoid invalidating the data submitted to CARB. Next, click OK to complete this menu.
Next, click the interface settings to enter the information about the interface device that will be used to record the OBD data. On the next slide, we'll show an example screen with the interface and device communications protocol options to select from the pull-down menus.
We will now use the pull-down menu to select the applicable SAE communication protocol for the engine, either the SAE J1939 or the SAE J1979 protocol. Enter the correct baud rate, either 250 or 500 kilobits per second, and finally, select the name of the interface device you are using to connect to the vehicle. Click OK when done.
When this menu appears, click Upload Results. After you select Upload Results, another screen will appear to prompt you to enter vehicle information before the test can begin.
From this menu, enter the VIN and license plate number in the corresponding fields. If the license plate is not available for any reason, please enter none. This is required information to successfully complete the test. You may also enter additional information that may be relevant in the comments section. Next, click OK, and the interface device will now connect to the vehicle and record all required OBD data. This process may take a few minutes to complete. Do not disconnect the interface device or turn the engine off during this process.
Once the OBD data has been recorded, a new screen message will appear to indicate that the OBD snapshot has been completed successfully. This notification will also request that you upload the data record to CARB. Select Yes as shown. Make sure the connection to the internet is not disrupted at this stage, as it is needed to upload the test data record to CARB.
Following successful transmission of the test to CARB, you will receive a final notification indicating that the OBD test and upload was successful. Click OK, and you can now close the testing program and disconnect the device from the vehicle. Congratulations! The OBD test is now complete.
After submitting the results to CARB, you will receive an automated message at the email address you entered when you started the test that informs you whether the vehicle passed or failed the OBD emissions compliance test. Please always check your tester account at cleantruckcheck.arb.ca.gov for test results, as this is where they are applied to vehicles for compliance. A passing test is needed to meet Clean Truck Check regulatory requirements. On the next slide, we'll go over some reasons a vehicle will fail the OBD emissions compliance test.
A passing OBD test submission should be free of indicators of emissions-related issues. Examples of emissions-related issues, including other conditions that may cause a vehicle to fail the OBD emissions compliance test, include an illuminated MIL or DTC, which we discussed earlier in the presentation. The OBD system's readiness monitors indicate the vehicle hasn't been driven enough to ensure sufficient time for the OBD system to check for emissions-related issues. The emissions compliance test is performed using an OBD testing device that is not certified by CARB. Only test devices that are shown on CARB's OBD testing device webpage can be used for compliance testing. And the submitted OBD data doesn't match data that would be expected for a particular vehicle make and model.
Once your test has been completed and transmitted to CARB, you can view the test results in your CTC Viz tester account. In the Test Details section, you will see a table with all the results associated with your login email address. You may click on the test ID number for detailed results, and you may click on the Pass/Fail for additional details. If the test results show fail, the pop-up will give you the reason for the fail. Please be sure to utilize your CTC Viz tester account to check the test results, as a test is not applied to the vehicle until it is visible in your tester account. At CARB's Credentialed Tester webpage, you will find FAQs that explain the failure reasons and suggested actions. Testers may print the test results by opening either the test ID or the pass page, right-clicking, and then selecting Print on their screens.
As we have now reached the end of this training module, let's summarize what you have learned about this course. You have learned about the OBD system and its purpose. You've learned what a mill is and its significance. You've learned the different types of DLCs that may be present in heavy-duty vehicles, as well as the data collected during Clean Truck Check OBD emissions compliance tests. And finally, you have learned how to perform a Clean Truck Check OBD emissions compliance test and submit the results to CARB.